Hey everybody, Mr. Judson here. It's Wednesday, June 3rd, and remember I told you guys I'm actually not really here right now on Wednesday. This is Tuesday that I'm making the video. And so I'm down at the hospital right now. My wife's having her surgery, and so tomorrow I'll have some kind of a worksheet for you guys to work on, some kind of practice. I won't be making a video on Wednesday. Today, yeah. All right, so yesterday we were talking about this idea of two vectors and adding those together. And if I can get them in component form, then it's really easy to add those together, okay? So we said that if vector A equals in component form x1 comma y1 and vector B equals x2 comma y2, then when you add those together, vector A plus vector B, you just get x1 plus x2, add the x values together, and then y1 plus y2. And so that's the idea that we want to build on today, is being able to add two vectors together. You know, remember, vectors can be a force that's pushing or pulling on something. It can be like if, you know, maybe one force is an airplane flying through the air and how fast it's going. The other force is the wind and how it's blowing the airplane off course. It could even be, you know, an airplane or a ship goes a certain distance and then changes course and then goes another distance. We can use that as two separate vectors, okay? But here's the question. How can I find these x, y coordinates easily for a vector? Okay, so remember, we said this yesterday. If I have a vector and it's in component form, it starts at the origin and goes a certain distance. And I'm just going to label this, I'll just call it n. Okay? A lot of times in physics, a force is measured in newtons. So they use n a lot for vectors. But it doesn't have to be a force. It could be a distance. It could be a speed at which something's traveling. And what I want to do is I want to find the xy coordinate for that. Well, to do that, I'm going to go ahead and draw a right triangle here. I'm going to call this an x distance. I'll call this a y distance. And usually we know the angle, we know the direction in which this vector is going. And so if I tried to solve for x, what I would do is I would say that the cosine of that angle theta is equal to adjacent over hypotenuse, so x over n. And I'll just bring that n to the other side, multiply, so I get n cosine theta equals x. So there's my x coordinate. And if I do the same thing for the y coordinate, this time I'll say sine of theta equals opposite over hypotenuse. And so I'll bring that n over and multiply, and I get n sine theta equals the y coordinate. So if this would have been vector A, what I could do is I could say vector A in component form equals n cosine theta comma n sine theta. And remember back when we first started doing the unit circle, we said that cosine is always the x coordinate, sine is always the y coordinate. See, that hasn't changed. The difference is our radius is not going to be 1, it's going to be something larger, so we just multiply by that. But this will give us the coordinates for anything. An airplane, if I know how fast the airplane's going, I'll just do the speed times cosine theta. Now, I got to be careful because an airplane bearing starts at north and goes this way. I got to make sure I find this angle. This is really, really important, you guys. When working with vectors, these angles have to be measured from the positive x-axis the way that we learned at the very beginning. Okay, really important we get that. With vectors, these angles have to be measured from the positive x-axis the way we started at the beginning. Not the way airplanes measure or the way that boats measure. You know, we'll use that information to figure out these angles, but I don't want to put those angles in here. Okay? If I want to know coordinates for vector b, I would just say the same thing. Vector b equals whatever the speed or you know, whatever, n cosine theta, n sine theta. And if I'm adding vectors together, really I just have to add these two things together and these two things together, and I've got what I'm looking for. Okay, let's do a practice problem, because I think once we do the practice problem, this will make a little more sense. All right, so usually when we talk about vectors, we talk about a force on something. And so here's a situation that I've run into a couple times. You guys have heard me talk about it. I go up in the mountains and cut down Christmas trees in the winter. And it never fails. There's always a car that goes off the road. And, you know, whether it's our car or somebody else, we always stop to help. And so this car went off the road. It's coming down this way and didn't realize it had to turn and skidded right off the road. So what we do is we'll hook up ropes or tow cables to that car and pull them out of the ditch. And so what I have is, okay, car 1 is in the ditch, car 2 is pulling back up the road this way, and car 3 is pulling this way. And so together, those two forces would be stronger than one car by itself. And so the question we want to try and answer is, which direction will this car actually go based on these two forces? It should really go somewhere between these two cars. It should go out, you know, maybe this way. I'm kind of cheating a little bit more towards this car because I drew a longer arrow there, but that's really the only reason. So we need to know some more information before we start this. So what I'm going to do is I'm going to put an XY axis into the problem. And I'm going to say that this angle right here is 20 degrees and this angle is 30 degrees. And this car pulls with a force of 120 pounds of pressure. This car pulls with a force of 150 pounds of pressure, lbs for pounds. Okay. And so the question is, in what direction and with what force, what's the magnitude and direction that car number 1 will go as these two cars pull on it? Okay? So remember what we just wrote down a second ago. I want to write these two vectors in component form. So for car number 2, I'm going to say that that's equal to 120 cosine 20, comma, 120 sine 20. See, what I have to do is I have to figure out from the origin what's the x, y coordinate that car number 2 is pulling towards. And so what this does is it gives me the force that it's pulling with in the x direction and the force it's pulling with in the y direction. Okay, so remember, we just wrote this down a second ago. N cosine theta, n sine theta. That's for car number 2. All right, for car number 3, that vector, so now because this angle is going in the negative direction, I have to call that a negative 30 degrees. Even though it doesn't say that in my picture, the way we measure angles from the positive x-axis is that would be a negative 30 degrees. So the components for this vector are going to be 150 cosine negative 30, comma 150 sine negative 30. Okay, so there's my vectors in component form. And then what we said yesterday is all you have to do to add these together is just do this plus this equals something. So my resulting force, remember how I said we use R for results? I'm just going to grab my calculator. Now I've got to make sure I'm in degree mode, so I'll just double check that. I am, so that's good. So I'm going to go 120 cosine 20. Okay, you guys should do this right along with me on your calculator. Go ahead and pause if you need to grab it. Plus 150 cosine negative 30. And I just hit enter, and there it is. So the direction that the car number 1 will go, its x-coordinate is 242.667. Okay, it's going to get pulled from the origin to this point. Now, here's the thing. I'm probably going to need to use this number later to figure something out. And so I want to store this in memory. And so all I'm going to do is I'm just going to go store in the x value. So store x, and there it is. I've got that if I need that later. All right, let's find the y coordinate. I'm going to do this one plus this one equals this. So 120 sine 20 plus, don't forget your parentheses as you're punching this in. That's real important. Plus 150 sine negative 30. And what I get is a negative 33.958. And I want to store that in my y coordinates. So I'm going to go store, and I'll choose the alpha button up here, the green one, and then y is where the 1 is, so alpha y. All right, so these two numbers are now stored. So here's what we're saying. Here's car number 1 at the origin, right? It's getting pulled towards this point right here. So I'm going to go out 142.667 units, down just a little bit to negative 33.958. This is 242.667. This is negative 33.958. And so now what I want to do is I want to figure out the actual force that's pulling on the car. Okay, the hypotenuse here is the actual force. So if we think to ourselves for a minute that this is an x-coordinate and this is a y-coordinate, and I'll call this r for result. So I know that x squared plus y squared equals r squared. If I want to solve for r, I'll just take the square root of this whole thing, and that's the magnitude of that resulting vector. So the magnitude of vector r equals the square root of x squared plus y squared. It's just a Pythagorean theorem. Okay? And then I want to figure out what this angle right here is. And so to get that angle, I would say that the tangent of theta equals opposite over adjacent, so that's y over x. So theta is going to equal the inverse tangent of y over x. Those are the two things that we're going to need every time we do a problem with vectors to convert this final piece that's in component form into an answer that makes sense. Remember, what we're trying to do is figure out the magnitude and direction. With what force are we pulling, and in what direction. Okay? So to finish this problem up, I need to say that my magnitude of my resulting force is equal to, and I'm just going to put this right into the calculator, because remember I stored this number in x and this number in y. So if I just go square root of x squared plus alpha y squared and hit enter, there it is, 245.031 pounds of pressure. 245.031 pounds. So now you can see why you'd hook up two cars. This car can pull with 120 pounds, this car with 150, and so together, based on the angles they're pulling, that's the net result. We get 245 pounds of pressure pulling this car out of the ditch. Right? It's not just 120 plus 150 equals 270. That would be true if the cars were side by side pulling the same direction. But they're not. If they did, they'd bump into each other and they'd damage their own car. They don't want to do that. All right, and so at what angle? So theta is going to equal, we'll take our calculator and we'll go second tangent of y over x. So alpha y divided by x. And the actual direction is in a negative 7.966 degrees. Okay? So a negative 7.966 degrees. Now in the real world, we don't really care what direction we're pulling. We just want the guy out of the ditch, right? I don't even care how many pounds of pressure. But it's just interesting to know that you're getting more pressure than just what one car can do by itself. Okay. Now, if this problem had something to do with, let's say, a ship, well, you know, the car is going in, car number one is going in this direction, okay? So if I had to describe that direction, if let's say this was a ship out in the ocean, I would have to say south so many degrees to the east. I would actually have to do 90 minus this number to see what that angle right there is. That make sense? All right, let's try another one. All right, so here we've got an airplane. It's flying with a bearing of 20 degrees. So remember, that means if you point north and rotate 20, that's the direction the airplane's flying. At 350 miles per hour. The wind is blowing 110 degrees. So we're going to assume that the wind is, the direction here is just being treated the same way as if it was an airplane. You start it at north and rotate 110 degrees. Okay? At 80 miles per hour. Find the actual speed and bearing of the plane. So what I'm going to do is I'm going to draw an XY axis. And I'm going to think if I start here and rotate 20 degrees, that's not real far. Something like this. So there's vector A for airplane. Okay? And it's going 350 miles per hour. And this angle right here was 20 degrees. So that means this angle should be 70 degrees. So I'm going to write vector A in component form. Remember how we just did the vectors for the cars? I want, in our formula, n cosine theta, so the force is 350 miles per hour. So I want 350 cosine 70. This angle has to be with the positive x-axis. I've got to use that angle right there. Comma 350 sine 70 degrees. When you write down these two coordinates, they'll always be exactly the same except cosine for x, sine for y. These two numbers will always be the same. Those two numbers will always be the same. All right? And so then we've got the wind. It's blowing at a bearing of 110 degrees. So if I start here at north and rotate, there's 90 degrees. I need to go another 20 down to here. Okay, so the wind is blowing this way. And I'm going to make this a smaller vector because the wind, call it vector W, is blowing at 80 miles per hour. And if I went 110 degrees, this angle right here is 20 degrees, but I got to call it a negative angle because that's how you'd measure it with the positive x-axis. So vector W is going to be 80 cosine negative 20, comma 80 sine negative 20 degrees. And all I want to do is add those two things together. Okay? Now, just think about it. If a plane is flying this way and you've got an 80 mile per hour wind going this way, that's going to push the airplane off course, right? There's no way it can't. And so this is one of those things that when you're flying an airplane, not just the pilots but also air traffic control, you've got to do a little math to kind of figure this out and how do we get the plane back on course. Okay? Now, they don't really do the math. They punch the information into a computer and the computer tells them how to correct it so that they get to the right destination. Okay? All right, so I want to add these two together. So I'm going to grab my calculator and I'm going to do 350 cosine 70, close parenthesis, plus 80 cosine negative 20. And I hit enter, and what I get is 194.882. Remember, these are components, so it's just an x coordinate. I'm going to store that in x. So I just overwrote the last x value that I had. I don't have to worry about clearing memory. Right? Once I store something new, the old one's gone. And now I need to do this. Here's a way to speed this up a little bit. Just arrow back up to where you have 350 cosine 70 plus 80 cosine negative 20. Hit enter and just change the cosines to sines. So put a sign there. Put a sign there. And what I got is 301.531. And I'm going to store that exact value in alpha y. So store alpha y. Here's how you can tell me that you stored things. Just go like this. This is stored in x. This is stored in y. And that's our resulting vector. So now what I want is the magnitude of that result. Just like we did yesterday in the homework, it's the square root of x squared plus y squared. Okay, so I'm going to go square root. You can just write this down to show your work. Square root of x squared plus y squared. That's all you have to write. Because we already know what x is, right? We've acknowledged that this is x right here. So I don't have to write that number again. And by the way, you really should write this down for the Central Washington test. It says on the directions, you have to show work to get credit. This is showing your work right here. Okay? So, second square root, I've got x squared plus alpha y squared. And so what I got is 359.026 miles per hour. And you might look at that and go, wait a second, how can the plane go faster? Well, the wind is either going to work in your favor or against you. It's either going to slow you down or speed you up. I suppose there is a situation where it could make your speed the same. But yeah, it's not unusual to get something that's larger. All right, so now the angle, I'm going to do inverse tangent of alpha y divided by x. And so what I got is 57.125 degrees. So remember, that's an angle with the positive x-axis. So the airplane is really going this way, and this angle right here is 57.125. For an airplane bearing, I want this angle right here. So I got to do 90 minus this. So 90 minus theta. And what I got was 32.875. So now here's my clear answer at the end. The plane is doing 359.026 miles per hour with a bearing of 32.875 degrees. There's my clear answer at the end. All right, let's try another one. All right, so here's a different kind of problem. There's an object, O for object, at the origin, and there are three forces pulling on the object. One force is pulling this way at 50 pounds. This angle right here with the positive x-axis is 25 degrees. And then that 45 degrees is between these two forces. There's another force pulling this way at 110 pounds. And then there's an 80-degree angle here, and this one's pulling at 90 pounds. And so the question is, what's the result on this object right here from these three forces? Now, I know you guys look at this and you probably go, 3? Come on, Judson. I don't care if it's 2, 3, or 20. It's done the exact same way. We write each of the vectors, we add up all the x coordinates and all the y coordinates, get our x and y result, and then answer the question. It's all the same. Okay, so you guys see if you can do this. All right, so my first vector is going to be 50 cosine 25, comma 50 sine 25. And now my second vector, 110 cosine. Now this angle, we've got to add these two together to see what this angle is with the positive x-axis. So that would be 70 degrees, comma 110 sine 70 degrees. And then my third vector, so I got 70 plus 80, that's 150. So I got 90 cosine 150 degrees and 90 sine 150 degrees. Now we just add them up. Okay? Go ahead and pause and see if you guys can finish that. All right, so I've got 50 cosine 25 plus 110 cosine 70 plus 90 cosine 150. So there's my x coordinate. I get 4.995. And I'm going to store that in x. So store x. Now we'll do the same thing for the y coordinate. So I'm just going to go up and get that last one, and I'm going to change all the signs into signs. And what I got is 169.497. I'm going to store that in alpha y. So store alpha y. Boy, don't accidentally forget to store, because if you do, there's a number in there, and you'll go ahead and you'll do everything else right, but you'll do it with the wrong number, and we're not going to know, because we don't look at these numbers and I can't square that in my head and then square root, after I add them together. I can't do all that and know if it makes sense or not. So really important we make sure we're storing each time. All right, so now this is my resulting vector. So the magnitude of that result is square root of x squared plus alpha y squared. I probably could just arrow up and find that and hit enter instead of doing it over again. And so what I got is 169.571 pounds of pressure. Now I need to get the angle. Oh. So I really should have written down equals the square root of x squared plus y squared. That's showing my work. I need to put that in there, okay? Theta equals the inverse tangent of y over x. So let me do that. Second tangent alpha y divided by x. And I get 88.312. Since this isn't an airplane or a ship, I can just say that the direction is this angle, and I know it's from the positive x-axis. Okay? So my final answer is 169.571 pounds of force in the direction of 88.312 degrees. All right, there it is, you guys. That's what we have for today. Is trying to take a force and write it as a vector, and then add those together, get a resulting vector in component form, and then we just have to change it back into what's the magnitude, like we did yesterday, and in what direction. So before I get you an assignment, just a reminder. So you're watching this on Wednesday, but for Thursday I won't have a lesson because on Wednesday I was at the hospital with my wife. I told you about this yesterday. She's having her last surgery, and so I'm just going to have a worksheet, kind of a review worksheet for you guys that I'll put on the Sway page, and that'll be our assignment for this Thursday. Okay, we've actually learned everything we need to learn now, and it's time for us to start reviewing anyway. And so that worksheet will be our first review to start getting us ready for the Central Washington final. That's it, you guys. I'll just go ahead and say it now. Have a good weekend, even though it's really Tuesday that I'm making the video, but you're watching it on Wednesday, but I won't see you on Thursday. So yeah, have a good weekend. Stay safe. We'll talk to you later. Bye. Here's our assignment. We're on C21 now. We're going to do page 458 and 73 to 76 and 84.